Okay, in this video, you'll see some cochlear implant programming software. I'll stop it as we go through it to provide a little more detail about what they're talking about. But this is what audiologists do when they're setting what we call the MAP, MAP, of the cochlear implant program. And there's 3 or 4 different companies that make cochlear implants. She's going to go through a couple of them. And again, I'll stop it and highlight things as we go.
The hardware and software for cochlear implants is different for each manufacturer, but all of them allow for telemetry measures. In the operating room, towards the end of the surgery, it's useful to measure impedances, which is a check of each electrode to confirm the internal cochlear implant device is functioning properly.
So if you remember, impedance is the opposition to the flow of energy, and so we need to make sure that the individual electrodes either don't have too much impedance or too little impedance, meaning they're not making contact and so forth. And so this is done in the operating room because it's not always the case that all 22, 23, 19, however many electrodes are going to function properly. And if that's the case, then they'll make modifications to how they stimulate. But that's a more advanced topic. But she's going to show you how they test that.
I'm in demonstration mode in Cochlear America software in order to simulate the measurement. I'm measuring impedances now of the 22 electrodes, which shows green for good electrodes and red for 3 of the electrodes. By clicking on details, I can now see that electrode 2 and 3 have low impedances, which is indicative of a short circuit, and electrode 12 has a high impedance, indicative of an open circuit. In addition to measuring impedances, the other measurement that may be performed in the operating room is a measurement of the electrically evoked compound action potential. For Cochlear Americas, the measurement is referred to as neural response telemetry.
Okay, so she said electronically or electrically evoked. It was wrong in the the subtitle. It should be evoked, EVOKED. Okay, and so what they're doing is essentially making the electrodes evoke an auditory potential, the compound action potential we call it, which is essentially like the ABR. So think of compound action potential as very similar to like wave 1 of the ABR response. If you remember, there's 5 waves that we look at.
Abbreviated NRT. In the software, I can select Auto NRT. I would typically select a basal electrode, an apical electrode, and a few middle electrodes.
So they're just assessing the action potential from the electrodes at different points. So that way you get an idea of how it's performing, high frequencies, low frequencies, and then mid frequencies.
I can view the tracings while the compound action potential is being measured. This information in the intraoperative setting is useful to confirm that the electrode array is in a position to evoke a neural response from the auditory nerve. This measurement can also be completed at activation and subsequent programming sessions to give an objective estimate of appropriate stimulation levels.
I want to go back a little bit there. And you can see right here, this is the kind of action potential there. You see this dip, okay? And so sometimes you'll see a positive peak, sometimes a negative peak. It just depends on how they're recording. But that's the action potential.
Of appropriate stimulation levels. For advanced bionics, this is the screen where the behavioral method may be used to set the stimulation levels, referred to as M levels. I'm going to present stimulation on each electrode using tone burst, and gradually will increase the stimulation to find the level that the patient
Okay, so what they're doing is they're essentially increasing the electrical output, telling the patient, let me know when this sound is comfortable. So M meaning most comfortable level. And then they'll do that. I don't know if she talks about it, but then they'll do that for higher outputs and try to keep everything within a comfortable dynamic range.
Perceives as most comfortable. So here I'm on electrode 12, increasing the stimulation, and then would go to a different electrode. Again, would find that level that the patient perceives as most comfortable and do this on several, if not all, of the electrodes. For Med-El, this is the fitting screen. At the bottom, various tabs can be selected to make changes to the parameters of the map. The processing strategy can be selected from this menu. This is where the frequency bands can be adjusted. In the automatic sound management screen.
So remember, those frequency bands are related to specific electrodes. So just like hearing aids have similar frequency bands that we adjust. Now, of course, they're not related to electrical stimulation. They're related to acoustic output. But hearing aids also have these frequency bands that are used to process output by frequency. Now, remember, if you had me for 340, we talked about an FFT, a fast Fourier transform, right? And that takes your complex signal and breaks it down into individual frequency components. That's essentially the first process of that, is to get all the signals into individual frequency components using something like an FFT.
Several changes can be made, such as the compression ratio, the microphone sensitivity, wind reduction feature, and the microphone directionality can be changed to either omni, natural, or adaptive.
So we talked about those, right? Compression is essentially once the sound hits a certain level, it starts to reduce the output, the gain, to keep it comfortable. And then they talked about microphones and directionality and all of that.
As mentioned, each manufacturer has different hardware and different software, but all have a way to perform telemetry for impedance measures, as well as the electrically evoked compound action potential, and allow for the use of behavioral methods to create a map with appropriate stimulation levels for the patient.
So there they gave you some examples of what they can adjust within a cochlear implant, very similar to hearing aids. It's just a different stimulation method, but hearing aids have all of those. She mentioned directionality, adaptive versus omni, right? We talked about that. She talked about wind noise reduction, microphone sensitivity, all of those things. So cochlear implants are kind of making their way to be similar to hearing aids. Hearing aids have had those features for a long time. And cochlear implants, you're seeing that more and more development and addition of different features to improve the listening situation.